Hello folks, welcome back to the Cookboot. Today we are going to talk about hexagonal architecture in our project. And I think it's, on one hand, hexagonal architecture, this is a design pattern, like a software design or system design pattern. You could also say it's a set of principles to follow. And I think it's really valuable, especially if we're talking about production grade applications, about non-trivial applications where non-trivial is more than just a few files. I think most of bigger projects definitely benefit from adhering to these principles. It's also important to think about these early on because hexagonal architecture will dictate how to structure our project. So what kind of folders should that be, where the files should be, in which folders and files which logic should sit, and what can import what. So it's, if we want to have hexagonal, it's quite useful to have it early on, to set it up early on, because if you already have a bunch of files, it will become way more effortful to convert a non-hexagonal project to adhere to hexagonal principles. So that's, again, as we are doing Cookbook as a proper production grade, non-trivial application, we definitely want to have hexagonal in it. In this video, we're going to look more into the hexagonal principles, what they are, and in a follow-up video, I'll show you what existing setup I already have in a Cookboot as an example, together with some files and logic, how all of that fits together in a real project. So, talking a bit more about the theory here. What is hexagonal? It's a number of principles. Two principles are really important for us in this one. One is it's a layered architecture. So it talks about some layers in your code or in your logic. And another thing which is really in the heart of hexagonal architecture is an idea of ports and adapters, which mostly are interfaces. So the interface, how you know it from general development. And a proper clean way of using these interfaces can allow for some really great layout for our application. To remind, let me refresh this. So to remind ourselves, let's imagine we have this simple use case where a user wants to get a recipe from our server knowing the ID. So this is like the simplest use case possible. And in this one, user sends us an HTTP GET request. Our web server checks, does some stuff, then queries the database, and if found, returns the recipe to the user. If we now conceptualize a bit, look at the logic of the web server, what we can see is in the middle, in this green web server box, as soon as we get the request to get the recipe with the ID, let's say yummy, first, of course, we need to do stuff like authorization, authentication, parameter sanitization, all of that kind of real important, but stuff which has nothing to do with our logic. Then we have to go to the DB and we have to request from database a recipe with the ID yummy and also the user ID of the current user, because of course each recipe belongs to some user. And then if we find a recipe, we return it, a recipe. If we don't find a recipe, we return a 404. On the right in a gray, I have Python-ish code, which kind of does the same. So we first have to check some auth, sanitize, do some other maybe stuff here. Then we try to get the recipe from the database. So database.get here. And then, for example, if we get a key error, which that's actually from Python dictionary, but you can imagine a similar one for database. So if there was no key like this in the database, then we set response status 404 and we return. If we have found the recipe, then we convert it to JSON. And oh, by the way, this is like, this is non-Pythonic, some Java habits. This should be like this. So we convert it to JSON. Again, this is not a real Python code, but kind of a pseudocode to explain what's going on. And then we return 200 because we found the resource. So that's what's going on here. You can see that this method, the current onGet method, actually is doing quite some work. And the worst is that actually a few things are mixing here. on one hand, initially, you see a number of methods which they do some non-application stuff. This is important logic, but it has nothing to do with application with our business logic. It's not about, how do we get recipes or this kind of stuff. No, this is technical things that should happen whenever we handle a request. And then there goes some very specific application code. Hey, where do we get the recipe from? We get it from DB. And then you can imagine there could be more stuff here, maybe we filter something or whatever. And this is not nice because here we mix application code with the non-application code, and even worse, we have here a very specific implementation. So here a recipe comes from a database. You can imagine that we might switch from database to cache, or when we do testing, we maybe use a mock, so not a real database. And in this class, everything is super hard coded. It will be definitely not nice and not fun to later extend the work with this class. An alternative, which is where the foundation of hexagonal architecture comes from, is to do something different. Instead of directly having application logic in this onGet, we can have an interface. We can call it something like a receive application interface. And we can say, hey, when we create our web server, we will get a receive application from somewhere outside, so someone else who knows what this should be gives us an application. And then whenever we need to invoke business logic, we always call just this one app.get method, and we don't do anything else. We don't do any other business logic inside. This is the only thing. And what's even better is that if for any reason this receive application has to become something different, like a mock for tests, because we have it in our initializer, it's very easy to just pass a different thing. So this is a way more least coupled or less coupled, a way more clean approach. If you follow this further, if you try to kind of do this for the whole application, something that emerged, like you can imagine several separate layers, separate chunks of your application. Modern hexagonal application selects these three layers: adapters, application, and domain. And here, adapters is all the codes, any files which have to do with something external to the application. So maybe we handle HTTP API requests. And then we know about the client, and client is something kind of outside of our application. And also in this chunk, we know about HTTP statuses. Again, this is not the business logic. So if we have a chunk of code which deals, sets, gets, or checks an HTTP status, it cannot be part of our business logic. It's definitely something outside. It goes to adapters. Database, if we connect to a database or to any external service, again, this is not our application. Our application might need to store or retrieve a recipe, but it should not know about a database or a cache or anything. Again, this is beyond business logic. This goes into the infrastructure logic. So everything that knows about something outside of our application goes to adapters. Then we have our application itself. This is all the business logic and wiring. So we'll actually not get from DB, but let's say get from somewhere. And we will a bit later look into how this somewhere comes into this place. Then maybe filter out some stuff, return the first element, this kind of things that are really a business process. So basically, if you would have a human doing the thing, imagine a situation where there is no computer at all. And when you need to get a recipe, you have a person who goes, grabs some recipe book, looks up a recipe and gives you, gives you a copy. So what they would do, basically that would be our application. And then domain defines the language. I mean, not the Python language, but the business language. So when we say, hey, we have a recipe, you know, our application deals with recipes, or our application filters recipe ID, or our application checks user ID, all those entities go to the domain. Domain might have business logic, but for domain, the business logic has to be absolutely confined to the entity itself. So inside the recipe, we can have some logic about the recipe itself, but nothing more. Everything which is kind of connecting few things, connecting entities, using different entities, all of that goes to application. Domain is just mostly is the language, the business language of our application. So these are typical, you can do whatever layers you want, but these emerged as really useful separation layers. Looking a bit more into it, there is a clear flow of dependencies which is suggested to follow. In this case, adapters know about application and domain, but application doesn't know about adapters. So basically you cannot import from application files, you cannot import anything which lives in the adapter files. It's invisible for application. And domain doesn't import anything outside of domain at all. Like domain literally knows nothing about, it's mostly definitions. There is one thing, of course, if you think about these adapters being some external things external to our application, there are two very different types of adapters. There are driving adapters. These trigger something in our application. So when we get a user request, an HTTP API request, it has to trigger something in our application. Hey, give me a recipe, or you give me top 5 user recipes. These will be driving adapters. These trigger something in our application. While they're driven adapters, these are used by our application. So when our application needs to save something, for example, in a database to persist, then our application uses some adapters. But as we mentioned, the dependencies, the errors go only one way. And so you can ask, hey, how can an application use a driving adapter if it cannot import from the orange space? And so to answer this, typically there are few more entities in the application. Let's look at the top, for example, first. What typically you do in the application, in the hexagonal architecture, you separately define an application interface. So interface which will contain methods like get recipe, or get top user recipes, or get all, or create new recipe. And then our application will actually implement this interface, while our HTTP adapter, the one which was doing the get request, the one which knows about for a 4 or 200s, that adapter will import, some way it has to get the application implementation. But in the code, we are going to use only the interface port. So our adapter will use the application interface, the port, while it will be actually in the constructor or initializes, it will be supplied an implementation of this port. On the other hand, our application defines another interface, which is a repository. And whenever our application needs to persist something, or to read from persistent storage, it will just write, repository.save or .get or .create or whatever, without knowing what adapter implements this. And so whenever we create an instance of our application, we will also need to pass a specific adapter. And this is the way how things are separated. Now you can see that application points only to the ports, only to the interfaces, and adapters, which can use or implement these ports, they actually know about these application ports. And then about the domain, everything stays the same. It's kind of the direction is the same. You can or you probably will see if you go, Google hexagonal architecture, you will see this picture instead of this. The idea is the same, but first of all, well, if you can use hexagon, why not to use hexagon? It's, especially if you do board games, this is definitely the favorite shape for many, many, many folks. Or computer games, Heroes of Might and Magic 3 for those who've played it 20 years ago, forever. Anyway, the idea is the same. We have adapters, application, and domain. And the same way, any dependencies point only inwards. So for example, here again, we could have an HTTP adapter on the left here and CLI adapter for, command line interface, which point to an application interface port. And there is another repository interface defined by the application, and that repository will be implemented. This is another one. See, actually, let's do a quick hotfix in production. This should point like this, because the general rule stays the same. Everything points inwards. And you can see on the right, I have defined like SQL adapter and also mock database adapter. Whenever we are going to do some testing, we are not going to use a real database majority of the time, so we're going to use a mock. One of the reasons why people use this instead of this is because here you can separate adapters. On the left, you can have a driver adapters, those which reflect some user input. And on the left, or on the left part, and on the right, you can have some infrastructure adapters, those which represent something useful for our application. So these will be used by our application through a port. Here I have few examples also to remind you. So let's go back for a second. While here you see that all the arrows point inwards, and these arrows represent who can import what, like literally in the code files. It's orange files that can write import something from application. Application cannot write that. Any file in the application area, in the blue area, cannot write import from orange, import from adapters. But from two perspectives, from the adapter perspective and from the application perspective, these are kind of different. So let's look on the left first. On one hand, in the top left, you see that adapter, HTTP adapter, for example, it uses application interface. And I have, again, a small pseudocode snapshot where we, in the adapter code, we would get receive application interface, and we will later use it to get a recipe. The same interface, the same application interface is implemented by our app service. So our application service implements this interface, and it can point to it, it can import it, because they are both defined in the blue area. So that's kind of the trick. That's the idea of this layered architecture with ports and adapters. And you can imagine something like class recipe application implementation, which implements an interface. And actually, again, here you can see that it kind of inherits. In reality, you don't want to do inheritance, because with interfaces, you're way better off with composition than inheritance. But this is pseudocode, it's just to show. On the right, we have kind of an opposite situation. So for ports which will be driven, which will be used by our application service will use repository interface. And it can do it because, again, both are defined in the same blue area, in the application area. And you can imagine here that when we create our application, in the initializer, we will get something like repo, and then we need that someone provides us a repository, an implementation of this interface. And then later we will just, when we need to get a recipe, we just say, hey, repo.get or repo.get ID. The same repository interface at the bottom, you can see it's implemented by the SQL adapter. Again, SQL adapter is still our code. We will write it, but it will live in a different folder. In the adapters folder, you could imagine it would be colored orange if you could color the folders. And here in this SQL adapter, it will be again a class which implements a receipt repository interface. It can import this interface because adapters are allowed to import stuff from application. To sum this up in a bit more concise picture again, and this is what we're going to use as a starter for our next video, is so we have adapters, applications, and domain with all the imports pointing inwards only. And then adapters are also split for the drivers and the driven, where drivers are the adapters which trigger some functionality. Typically, these represent user interfaces like HTTP, API, CLI, things like that. And the driven adapters, they represent some kind of infrastructure or things that our application uses to work. So databases, external services, you can also think about a logging system, monitoring system, whatever that application uses. And let's finish it here. And with next video, we're going to see how exactly this is implemented in the Python. Thanks for being with me. Wish you a wonderful day. Ciao.